Okay. Welcome all our participants on our MROL session 20B. It's a workshop session, second session, and the title of the section is Augmented Virtual Reality and Immersive Technology in Education. And short introduction, we have scheduled 3 presentations. Our session is a journey to the world of new technology, to the virtual worlds, and its implementation in didactics. The roots of the technology is in 3D visualization, which have the roots in 90s, 80s, and then the new technologies like augmented virtual reality, immersive technologies, mixed reality, and so on were development. The development of technologies leads to change pedagogy, and now the new ideas comes to life. For example, didactics, didactical engineering, connectivity, and so on. All of us knows about it, and this is the journey in the world of such technology. I see that our presenter, Oksana Kluczko, is present. So please share your presentation. The title of the presentation is Using the Virtual Reality Technologies to Computer Science Teaching in the Secondary School. So please start the presentation. The stage is yours, the screen is yours.
Okay, thank you, Pavel. Dear colleagues, dear conference organizers, our presentation is Svetlana Tkachenko, author. Okay, please.
Yes.
Thank you.
Good morning. Good morning, dear colleagues and conference attendees. My name is Svetlana Tkachenko, and I would like to present the work devoted to using virtual reality technologies for teaching computer science at secondary school by Oksana Kluczko, Svetlana Tkachenko, Irina Babichuk, Vasil Fedorets, Tatiana Galich. So before we transfer to the key points of our research, it is necessary to admit the aim of our work. And I must stress out that also topic which concerns virtual reality and augmented reality in education is being covered in the works of foreign and domestic scientists generally. The study of the usage of virtual technologies in secondary school is still a little bit insufficient. So we want to fill the gaps which still exist in the topic coverage, and especially our aim is to investigate the potential possibilities of using virtual reality technologies for teaching computer science in secondary school as an innovative technology. Therefore, to reach the research, we use different methods, such as literature analysis, pedagogical observation. We also made some questionnaires, used diagnostic methods, used the method of pedagogical research, and of course, to provide the result that our research is ground truth. We used some mathematical statistic methods, and also we use design in order to create our own apps which can help us in our research. So actually it is very important to realize why virtual reality technologies for educational purposes are worthy of study and how they can help in reaching main educational goals. Generally speaking, virtual reality is a really powerful tool for demonstration and visualizing because it can show us things how they really are and make us closer to them. For educators, it opens up different possibilities to simulate processes and events, and it can really make the level of lessons interactivity when we are speaking about secondary schools really high. And virtual reality can help to diversify lessons and make them more interesting. After all, it can make the process of creating different educational means and forms much easier because it can be useful in the process of conducting different virtual lessons, teleconferences, video conferences. Also, it can be handy while creating different virtual museums, laboratories, planetariums. It is really powerful when it comes to some sort of advanced way to visualize different things and simulating processes. Of course, as it is used usually with the help of different apps and additional tools which can actually provide this kind of advanced visualization. That's why it is quite easy to use it in the interactive classes, and it can be used as an additional helpful tool in the process of flipped learning approach for project-based learning, and it can also be used as an additional mean for them creating pupils' independent work and so on. But it is also quite obvious that the usage of virtual reality technologies generally, despite of its general attractiveness, is also impossible without different resources and, of course, the necessary equipment. And it is very important, especially when it comes to its usage at secondary schools, to use the suitable software application and platforms, because it is not just enough to satisfy the necessity of being interactive and visualizing. It should be adapted somehow because of the its main goal, who is going to use it and for what purposes. So the right choice of the platform which can satisfy all the necessary important requirements is really a problem. And for our research, we made a choice to use CoSpace's DO environment. This choice was preceded by the analysis of a number of foreign and domestic experience studies in the use virtual reality technologies and CoSpace's DO environment. And we can conclude that CoSpace's DO environment is really a very good example of such kind of a platform for secondary schools because it can be very helpful not only in the usage but also for the creation of different kinds of virtual reality apps, and it is a good choice for especially educational purposes because it was actually created for such kind of a reason. So to make our research more effective and more adapted to the prior educational goals which we saw before we created our research, we developed two didactic software apps based on the core EduSpace environment. It's Excel on a Forest Glade and Tower of Henry apps. It's just the titles. And these apps are based on the interactive environment for the development of a 3D object. And they are actually the apps for which can represent the virtual reality and are made with the usage of 3D visualization. When it comes to the first app, Excel on Forest Glade application, it is created and of three action scenes, seen in the terms of spaces. ADO is just some parts of our application which are logically separated from each other. And there are three such scenes in the Excel on Forest Glade app. The first scene has a form of some forest glade on which in canvas with cells of a Microsoft Office Excel spreadsheet is it is placed here. The scene second is an exposition of slides of the educational presentation, and actually this scene is useful when it is necessary to teach students a new theme. In our case, it is when teaching them theme tabular data with the usage of Microsoft Office Excel, and its main goal of its creation was the mastering the theoretical material of tables. And finally, scene 3, it's actually for the testing the effectiveness of the topic, which should be mastered in the scene, in the second scene, and it is some form of interactive test. The second app which we created is devoted to the algorithmization, and it is a tool Tower of Hanoi. As you can guess from the title, it's for the it's devoted to the algorithm with the same name, Tower of Hanoi. And actually, this app can help students to master this algorithm, and it has two main logical parts. The first part is some kind of demonstration part, because we have there the interactive playground where students can see the visualization of this algorithm. So how the task with Tower of Hanoi should be solved. While the second scene is for the actual testing of students' skills, and is just for interactive usage of this algorithm, because the main aim of that second thing is to solve the task with having these towers built at the end. And to find out how generally this VR didactic software can be used in the secondary schools, and therefore we can test the usage of virtual reality generally. We tested it on the basis of the Regional Scientific Lyceum Boarding School Affinity Humanitarian Pedagogical College. And there on the slide, you can see the test or the test of evaluation control in control and experimental groups in the topics of tabular data processing and in the topic of algorithmization. And you can see that these results are quite homogeneous, so there is no very statistical important difference. And just to see if we can obtain some better results with the usage of this virtual reality apps. We also obtained some questionnaires beforehand in order to realize if we need something else, what really we need also to include in our research to do it more effective. And we obtained some questionnaire with the which aim for the respondents was to rank some organizational conditions when it comes to providing virtual reality in the educational process, and in order to find out what are the most important ones and what we should take into account firstly, which is the most important. And as you can see from these results, the highest rank got availability of the necessary technical support for viewing virtual reality applications, and a little bit less points got availability of the necessary software for the development and use of virtual reality, application of effective forms and methods of appropriate competencies formation in students, formation of students' positive motivation to study the chapter, and availability of the necessary methodological support for conducting lessons on the study of chapter. And as we can conclude that all of these conditions are important. But the first one and perhaps two are first. Yes, they are the most important and got the highest rank because they are more decisive than the last ones. So it is really a problem to have the necessary technical support. Yes. So after we concluded our research and actually provided the virtual reality in the educational process of Vinnytsia Lyceum, and we concluded that the educational results were quite better than it was at the start of our research, and to check if it really is, we provided some statistical methods for the checkout, and we used Wilkinson's t-test in order to check if we should reject or accept null hypothesis for the if it is really effective to use virtual reality in the educational process. And with the usage of different tables with critical values for statistically important results, we can conclude that in both cases, I mean in the case of usage Excel on the Glide app and Tamam Henry app, hypothesis now should be accepted, and it means that the usage of these apps in the educational processes makes it more effective. Also, as an additional part of our research, it is very important to get some feedback from students themselves to find out their own motivation and their opinions about the usage of virtual reality in the educational process, how interesting it could be for them, and if it is also interesting to find out if they really had some previous experience with the usage of such kind of technologies in their lessons before. So we also conducted some questionnaire. Firstly, in order to find out and what number of respondees can be considered as a significant one, so we can lately generalize the obtained result. We used this formula, which is based on the general amount of statistical population, and also use some students' confidence coefficient. We found out that it is important to have the required number of respondees is 384 students, and as a result, 387 secondary school students of Ukraine took part in the questionnaire in order to determine their interest in the use of virtual reality didactic software in computer science lessons. And according to the results of this questionnaire, we obtained the following results, that this questionnaire showed that students are generally interested in the use of didactic virtual reality software in computer science lessons, and the percentage of answers yes to all questions of the questionnaire was more than 60%, which more than that for answers no was 20, a little bit more than 20%, and when it was undefined, so without answer, it was less than 20%. So we can conclude that the general interest and motivation exist for the students, and the usage of virtual reality in the lessons. And I must also admit that the answers, the questions which we used were based on their motivation to actually the general motivation, if they are generally interested in the usage of such kind of technologies, and also if they want to try out it themselves. Like the first question was about as if they are really interested in using detective software or virtual reality in computer science lesson, and this first question scored the one of the highest percentage of positive answer. And also the question, the fifth question about if they would like to independently develop some virtual reality software apps in computer science lessons, if they really want to try out it themselves, also scored quite a high positive answers, as you can see from this table. So to conclude and to make some final points about our research, it must be said that based on the analysis of the ways of using virtual reality didactic software, Forest Excel on a Forest Glade and Tower of Hanoi, and determination of students' interest in these digital products, the study reveals that the potential possibilities of using virtual reality technologies for teaching information in secondary schools, and we can conclude that these technologies really opens up opportunities for an innovative transformation of the educational process to make it more interesting, and you can see from the questionnaires from students, which can also make their motivation and interest higher. The methodological basis of designing, development, and use of didactic software, virtual reality, Tower of Hanoi, and Excel on the Forest Glade with the use of cost-basis reduced service in computer science lesson in secondary school were developed and researched, and theoretical and practical results, conclusions, proposals, and recommendations were formulated in the study, and these results can be used for further research in this area in the process of designing and using other didactic tools which are based on virtual augmented reality technologies in the secondary school. Thank you very much for your attention, and I'm ready for your questions.
Thank you very much. I see these questions on the chat. I read the question. Kennedy Kravtsov. Dear Hennady, you have consequently demonstrated the benefits of using VR, AR technologies in educational process, but there are technical difficulties in using these technologies, especially in school. These are financial difficulties and the absence of a software market. How do you see the solution to this problem? I see that Oksana Kloczko answered the question. Please answer online. Oksana?
Okay, thank you very much for your questions. First questions, it's why now one moment we have but they're teaching difficult in using these technologies, especially in school. There are financial difficult and the absence of software make. How do you see the solution to the problems?
Yeah,
okay, thank you.
Answer.
Okay, we looked this problem. Dear Hennady, thank you for your questions, and we see a solution to this problem in the use of free software, minimize of cost for this software used, and як приклад, вибачте, мені так швидше відповідати. Як приклад, ми використовували CodeSpace CDU середовище, воно є безкоштовним. І якщо залучати, наприклад, мінімізувати витрати, то залучати учнів, використовувати безкоштовні, наприклад, проекти Google і виготовлення окулярів, і тим підвищується мотивація. От. Також, я знаю, що школи, багато шкіл беруть участь виграють гранти, проекти, якщо вже більш популярне обладнання використовувати. А також, в принципі, школи на сьогоднішній день, як ми зацікавилися цим питанням, неодноразово його вивчали, більш адаптовані до використання таких середовищ віртуальної реальності і добре фінансуються, тому, скажімо так, на закупівлю обладнання, зокрема окулярів, є можливість в школах. Саме в школах, тому що заклади освіти, вони, в принципі, змушені самостійно закуповувати. Далі було питання щодо кількості учнів, які брали участь в експерименті даному. То так, тут я хочу зауважити, що ми вивчали лише потенційні можливості використання даного середовища, і тому одразу ж я дуже дякую, по-перше, всім, хто задавав питання. Це дійсно слушні питання, і на них вони потребують відповіді. На Вінниччині нашим Державним педагогічним університетом проводились тренінги з навчання учителів використання саме віртуальної реальності засобів і Space. Тому дану проблему, і по-перше, в нас також навчаються наші майбутні вчителі, які працюють у цих же школах, зокрема Ірина Бабійчук. Вона є студенткою-магістранткою, і також вона працює в даному коледжі. Тому у нас з навчанням вчителів не було проблеми. Знову ж таки, повторюся, по-перше, ми тренінги проводили на базі нашого університету. Зокрема, я, скажімо так, і Світлана Ткаченко, ми разом готували цей тренінг і проводили серед вчителів Вінницької області. І Ірина Бабійчук, знову ж таки, магістр і магістрантка, і вона працює в даному коледжі. Тому це питання на базі Вінниччини було вирішено. Дійсно, це є проблема підготовки вчителів, проте ми бачимо їх підготовку на курсах підвищення кваліфікації. Щодо обсягу, знову ж таки, ми вивчали потенційні можливості використання засобів віртуальної реальності в школі. І масовим був експеримент, в якому брало участь 384 учні. Цей експеримент був масовим. І якраз результати даного експерименту показали, що зацікавлені учні, і якщо брати перше питання, яке задавалося учням, чи хотіли б ви використовувати засоби віртуальної реальності, то 97%. Хоча учні, які вже мають досвід, їх було всього 50%. 384 ми брали статистику, кількість учнів, які навчаються в школах взагалі в Україні, і за допомогою критерій студента визначили кількість, це 7-8 класи. Це 384 учні. У нас там 387 трошечки більше. Дійсно, там продовжують надходити відповіді, але ми вже їх не враховували надалі. Дякую вам за питання. Надіюсь, що я відповіла.
Thank you very much for the answer. I'm very proud that I'm with you, and I hear that you engage in the process. I think that virtual reality and such technologies are very motivating and attractive for students, and I think that this is the beginning of the way which lead us to and here I have to put a question mark. Okay, I think that your answer was wide enough for also for Maria. We are out of the time, and we have to jump to the next presentation. Please forgive me that I haven't mentioned other authors of your presentation, because I knew that it will take a lot of time. Please start the presentation, the next presentation. And the next presentation, Natalia Soroko, Svetlana Lutvinova, the benefits of using immersive technologies at general school. Thank you for the previous presentation. It was very, very interesting, and research are also very interesting and should be published, yeah, and can be interesting for all our professionals. So please, Svetlana, share your presentation and start your presentation.
Do you see?
Yeah.
My presentation? Yes.
Yes. Okay.
Okay. I can. Okay.
The stage is yours, please.
I greet all the conference participants. I'm Natalia Soroko. My co-author is Svetlana Litvinova. Our report is the benefits of using immersive technologies at general school. The development of information and communication technologies, e-learning, the emergence of a new generation of students and other factors are led to a change in the paradigm of education, etc. Thus, teachers should seek the necessary tools to organize the learning process to ensure the formation of key competencies in students and increase their motivation to learn. In the conditions of the pandemic caused by COVID-19, the technology of mobile learning as a kind of distance learning with the use of mobile phones, smartphones, e-books acquires special significance. In distance learning, the teaching of theoretical material is sufficiently well implemented by simple means of audio or video broadcasts, placement of text materials or presentations. A significant problem is in the organizing practical, laboratories, science school trips, tours, etc. Therefore, the main task of our study is to replace real learning with virtual VR and augmented reality AR as an immersive technologies IT and are the possible approaches in terms of distance learning and quarantine. In a recent survey of faculty, 81% of respondents said that VR, AR, and mixed reality MR will be key educational technologies over the next decade. Effectively integrating these technologies into the curriculum requires careful planning and numerous resources. In addition to adopting and incorporating the technology itself, institutions must consider related efforts, including faculty development, instructional design, learning space integration, infrastructure assessments, and governance, policy, ethics, and access equity. The purpose of the research is to analyze the use of immersive technologies for school learning and to identify the basic benefits of using immersive technologies at general school. Immersive technologies are methods and devices that create an effective identification with immersive media through sensory stimuli that use simulation and displays for humans immersive into virtual worlds which may not always be available in real life. It's a combination of real environment and digital technology via using interactive activities, and are the integration of virtual content with the physical environment, allowing the user to naturally interact with mixed reality, which includes two main types of reality, both AR and VR. Virtual reality VR and augmented reality AR are two closely related technologies that have some differences and represent a new direction in the development of digital technologies. VR creates the likeness of the real world through technical means. The effects created by projection penetrate the human brain and cause sensations as close as possible to real ones. AR superimposed images are integrated through the use of information and communication technologies via mobile devices such as the camera of a computer or a mobile device laptop, tablet, or mobile phone. AR is characterized by the inclusion of digital information, images, video and audio in real space, tries to combine the real world with the virtual environment, allows users to interact with both physical and digital objects. VR is characterized by the following factors. 1. Presents the illusion of being directly in another place, the world. 2. Immersion sensory organs process information received from objects and events of the virtual environment. 3. Involvemental thought processes are focused on virtual interaction. AR superimposed images are integrated through the use of information and communication technologies via mobile devices such as the camera of a computer or a mobile device laptop, tablet, or mobile phone. AR is characterized by the inclusion of digital information images, video and audio in real space, tries to combine the real world with the virtual environment, allows users to interact with both physical and digital objects. The table shows the differences between the traditional learning and learning using immersive technologies by such indicators as teacher's role, student's role, type of information communication, teaching methods, teaching material. The role of immersive technologies in education can be determined by such criteria as gaming experience, social role, simulation in the learning process, importance in life and learning, acquisition of knowledge and self-knowledge. We must take into account when using immersive technologies, especially when using it in schools teaching, the negative impact possibility on human health. Scientists define the so-called simulator disease, or cyber disease, as a common disease when using virtual reality equipment, especially main displays. Despite these challenges, which will be explored in the IT use of school learning, these technologies are important for the future development and improvement of education. To achieve the purpose of our study and also to clarify the problem of using immersive technologies at general school, we will use the following methods. Systematic and comparative analysis of pedagogical, psychological, philosophical, sociological works, methodological and specialized literature. Analysis of the pedagogical experience of using the immersive technologies in general school. Synthesis and generalization to formulate the main points of the study. Interviews and questionnaires of teachers about their attitude of the use of immersive technologies at general school. We looked at the sites that offer the most popular IT in studies, which analyzes the role of virtual and augmented reality in education. We summarized and highlighted the examples IT for any school subjects after that. Molecule VR and in-cell VR cardboard for biology. Molecule VR is an educational virtual reality app about how biological cells communicate. In-cell VR cardboard is a game for cell study. The Brain AR app, Education XR, and the Body VR for anatomy. The Brain AR app is an animated model, audio descriptions for parts of the human brain. Education XR is an extended reality XR platform used to deliver the most immersive education content possible for native mobile, tablet, desktop, and virtual reality applications. Nano 2D and MEL Chemistry VR for chemistry. Nano 2D is the virtual environment for studying two-dimensional materials, serving as an educational and research tool for advanced materials science. MEL Chemistry VR is a collection of chemistry VR lessons, which are aligned with the school chemistry curriculum, covering all of its main topics. Handwaver, VR Math, and GeoGebra 3D with AR for mathematics. Handwaver is a gesture-based virtual mathematical making environment, where users can construct uni, 2, and 3-dimensional mathematical objects through iterations of gesture-based operators. VR Math, students to understand and educators to teach 3D geometry. GeoGebra 3D with AR is an application for representing and studying various geometric shapes. Virtual iSchool and Class VR Physics for physics. Virtual iSchool is basic thermodynamics, specific and molar properties, ideal gas and cubic equations of state. Class VR Physics is an open platform, supporting virtual, augmented, and mixed reality curriculum content, as well as allowing students and teachers to create, upload, and share their own content, creating a collaborative community of global educational resources. Google Arts and Culture Virtual Museum and Archive for Art. Google Arts and Culture Virtual Museum provides an opportunity to visit museums around the world, examine paintings and other works of art in detail, listen to their history, etc. Archive is creating visual effects for films that is performed on a mobile device in real time. Music Room VR and AR Piano Tutor for Musical Art. Music Room VR is designed as a professional musical instruments, integrated with Bitwig 8-track, the leading expressive audio workstation. AR Piano Tutor recognizes the piano including the notes of its keyboard and determines the three-dimensional position and orientation of the piano in a 3D space. This is done with a precision of up to 1 centimeter. We ask the teachers 94 secondary school teachers, as experts, see the proposed IT Google Expeditions, MergeCube, Robotics in VR, Virtual Museum, Nano 2D, Virtual iSchool, Class VR Physics, InCell VR, and answer the questionnaire that about using IT in class or e-learning. The survey was designed where the pros and cons of immersive technologies could be visualized, and in such a way that each teacher responded with a degree of satisfaction, classified in 5 blocks from lowest to highest satisfaction in strongly disagree, I do not agree, agree, totally agree. According to the results of the survey of teachers about using IT in class or e-learning, the most understandable and used are such IT, Nano 2D, InCell VR, Virtual Museum, Google Expeditions, MergeCube. Can highlight the main advantages of IT, providing the ability to change the relative size of the pre-investigated objects, which leads to the visualization of objects of the micro and macro world. Creation of models of the phenomena or processes which cannot be directly and clearly registered by bodies of senses of the person. Visualization of abstract models and production of objects that have no form in the real world. Focusing students on the study of specific objects without distraction to external stimuli, which gives them the opportunity to focus fully on the material. Immersive technologies can be used as a supplement, but not as a complete independent training course. They should be used in the study of the most complex topics of various subjects and for training of professional skills in various activities. These tools significantly improve the learning process and students' perception of scientific material, expand their opportunities for research, laboratory work, etc. Each of the immersive technologies needs specific instructions and guidelines for their implementation in school and in a particular subject. Thank you for your attention.
Thank you for very interesting and impressive presentation. I'm opening the part questions and answers. I'm opening the discussion. Maybe you have any questions from the room, co-working room. If you have, please. No questions. We have 2 questions.
Pavel, may I ask a question?
Yeah, please.
I formulate a question in chat.
Yeah. I read my question. I read the article, and it is not clear for me what the word experts means. It means that the teachers in general, the informatics or biology, or in general, or teachers that using the mentioned software, the mentioned technology. Please answer.
Thank you very much for your question. This technology really in English language, but we have many products for translation.
I can't hear you.
Yes, we tried 18 tools, 9 augmented reality and 9 virtual reality for many subjects. This is written in the article. But I want say that for teacher we have selected the most affordable or those that have a demo version such as the Mergicube, which proposed 3 weeks can be used for free. Thank you.
Are they use the technology in practice? The teachers which are in your research? Are they use the technology?
Yes.
In practice? Okay. Okay, thank you. And the next question, Hennady. You have researched the problem of using immersive technologies in the education process in various academic subjects. These are mainly developments of foreign firms. How to solve the problem of providing Ukrainian schools? First question. And the second, what opportunities do you see for the Academy of Pedagogical Sciences?
I'm so sorry.
You can answer in Ukrainian.
I answer
I
it in these questions. I'm sorry.
Okay. Okay. Any questions?
Yes, it's interesting to me. I would like to say what teachers had been involved in your survey. Got it?
Yes. Thank you very much for your questions. Our teacher, which answered on our survey, was 94, and this teacher in secondary school. I'm sorry, I cannot hear.
Computer science, biology. What subject did they teach?
Yeah, no, we cannot research such subjects.
I mean teachers, not you. I mean teachers.
Yes. In biology, chemistry, music, and language and literature.
Okay. Did they use this technology, immersive technology? Did they have they already used this immersive technology or not? Or they would or not?
They used this technology, but only demo version.
Okay, thank you.
Thank you.
Okay, thank you very much. You can use Ukrainian. I can understand Ukrainian a little bit, but I can't speak Ukrainian. Yeah, sorry. Okay. Any questions? Please? No? So thank you very much for your very interesting presentation and a lot of information that I think will be useful for our participants. Yeah. And now, thank you very much. And now it's time to moment. I must find program. We have to skip to another one presentation. Sergii Woloszynow, Halina Popowa, Wasyl Czerniawski, Andrzej Petrowski, Tamara Pintosowa. and the presenter Sergei Voloshinov. And the title of the presentation: Quality Assessment of Future Navigators, Training by Means of VR Technologies. So please share with us with your presentation and start the presentation.
Good afternoon. We prepared the presentation, so at the moment we are ready to show it. Just a moment.
Okay, we are waiting.
Thank you.
I think that discussion in reality, not virtual discussion, would be more interesting for all of us.
Sorry for technical problems.
No problem, we're waiting. Still waiting.
Ladies and gentlemen, to your attention there is scientific paper on topic Quality Assessment of Future Navigators Training by Means of VR Technology. The trend of recent years is the digitalization of navigational equipment and the compliances of technical aids to navigation systems, which are used during vessel traffic. But world statistics show that the human factor remains the main cause of maritime incidents. The said statistics are replenished by several reasons. Fatigue of the watch personnel investigated by Ukrainian scientists, uncertainty and incompetence of the command personnel, lack of necessary professional skills of key crew members, captains and officers in charge of the watch. It has a negative impact on the safe operation of the ship and the lives of people. It is therefore relevant to improve the quality training standards of future maritime professionals, who should be trained to work with a variety of information in digital form, be capable of choosing effective forms of ship management to ensure the safety of navigation, and be responsible for the management decisions taken. The aim of the study is to select a model for increasing the efficiency of training material in a practical content using virtual technology for the ability to ensure safe navigation. The Academy has implemented a model for training of future maritime specialists. Model elements are blended learning, which is implemented with LSM Moodle and traditional classroom or laboratory teaching. VR simulator, which provides formation of competence for execution of tasks according to the created algorithm. Real simulator, on which the real training takes place, and practical training on board. In recent decades, information technology has been actively implemented in navigation, in particular electronic chart display and information system (ECDIS), which integrates various navigational devices, provide information in real time with the possibility of superimposition on the electronic card, for example radar coverage. The purpose of such system is to improve the safety of navigation, including combining of all possible information for navigator to make a decision. Navigation is significantly different from other technical specialties due to the use of the entire amount of acquired knowledge at once for the analysis of data from technical means of navigation, navigation and meteorological data, GPS, echo sounder, IES, VHF control and radar data, and ARPA. The blended learning system taken for research consists of electronic learning, theoretical course of lecture material. For each lecture, appropriate testing of cadets is carried out. Methodological material, presentations and videos posted on page of discipline, navigation and information systems is carried out. Classroom simulator course to acquire practical skills in using ECDIS. As shown in previous years' estimates, this is not enough, since it is difficult for students to take large amount of information together in order to make the right decision when the time for making it is limited, due to the rapid change of navigational circumstances and the great inertia of the ship. It is proposed after blended learning to use VR technology for preliminary knowledge of dangerous sections of the crossing route, which may be approaches to port, terminals, canals, and other narrows. At the same time, cadet, being at home and having a VR helmet and glasses, enters cloud resource, which broadcasts to the VR helmet on-screen user. Visualization of the simulator, coning, display, overview, ECDs, radar, and other elements of the navigation bridge. During the passage along the route, instructor commands are provided, and attention is drawn to the indicators of the radar in overlay mode and other navigation devices integrated into ECDs. This is, cadet may pass any difficult part of the route once more. He has the opportunity to go through as many times as he needs to find out all the subtitles of the ship steering under such weather navigational conditions. The chosen model in training is VR technology using cloud services, where the simulation of the exercise is viewed by cloud server. The simulated situation is displayed to the student over of personal computer with web browser and headset. The data about students' actions is transferred to controller and web browser, further to cloud server to further change the situation. Additional advantages of the proposed use of VR technology are building of the environment which is perceived by the navigator's senses. The student independently perceives and rethinks all the information. It can be implemented using AR content on smartphone tables and interactive whiteboard. Method of statistical analysis were used to determine the authenticity of the proposed model. There were selected equal group 1 and non-equal group 2 samples that are not linked. In the study, there were used analysis of stakeholders, cadet shipboard training reports, regulatory documents on professional maritime education, competence-based approach and assessment of competences, analysis of scientific and methodological literature, dissertation research, curricula, texts, and teaching aids, regulatory documents on the problem of organizing the educational process in institutions of higher maritime education, scientific literature, and technical documentation. At the beginning of the academic year, a cross-section of knowledge was conducted in the research groups to determine the level of competence for the possibility of using ECDs. Each research group of cadets was divided into two subgroups. Due to the limited number of places on the simulator bridges, 8 units. That is, when conducting a lesson on simulators, the number of cadets is limited, up to 16 people, 2 students per 1 navigation bridge. For blended learning, subgroup A, according to the usual method of self-preparation for practical exercises, control subgroup B, using the proposed VR technology of familiarization with hazardous area, research group. A representative sample with a confidence probability of 95%, a confidence interval of 5%, and a total population of 15 people is enough to examine 14 students in each subgroup. Cadets' evaluation of Group 1 and Group 2 was carried out according to the criteria of speed and accuracy of the final check assignment. Based on the results of experimental training using VR technology, there is better simulation of navigators' practical skills according to research data in Group 1 by 13% and Group 2 by 19% compared to the usual blended form of education. At the same time, there are no cadets who did not cope with the practical task. The results can be considered significant and experiment was successful in both groups. The proposed model of training in the direction of navigation is working option for obtaining of difficult professional navigator. The advantages of using VR technology are significant improvement in the acquisition of theoretical material and practical navigational skills in difficult weather conditions and on difficult sections of routines using virtual reality. The possibility of using such technology remotely. The disadvantage is the difficulty of developing exercises and related software due to the large amount of data for analysis. Further research can be to construct an appropriate system of catalogs, each of which contains a little of such dangerous areas. A student choosing the appropriate passage receives a list of files that must be familiarized with before the practical course on the simulator. The latest results in VR technologies can also be introduced in the future to perform actions according to the algorithm and increase the realism effect of the process. These directions of VR technologies development in teaching can be introduced in most disciplines that require the implementation of management processes for complex systems with attention to the environment. Thank you for your attention.
Thank you very much for your attention, for your patience. We'll be really glad to meet you at our academy and to share our experience. Thank you very much. So if you have any questions, we'd like to answer them with a pleasure.
Thank you very much. I see one question. How do you see the prospect of integrating VR technologies in distance learning system?
Thank you.
Please answer. Gennady Kravtsov. Yeah, please answer. How do you see the prospect of integrating VR technologies in distance learning systems?
Дякуємо за запитання. В нас в академії вже інтегровані VR-технології в Moodle, інтегровані як в навчальному плані, і вже поруч з традиційними лекціями, практиками, які ми можемо проводити на Moodle і дистанційно, у нас вже є можливість проводити декілька лабораторних і практичних занять за допомогою VR-технологій. Ми через 2 тижні відкриваємо нові 2 лабораторії, і там це вже все буде зроблено. І зараз ми вже маємо таку можливість, і вони вже вже є, ми використовуємо вже.
I see that your project is a good practice of didactical engineering and didactics. I see that there is a lot of many interesting parts of such a new direction, for example, in didactics, and the whole parts are incorporated in your project. I have one question to your article, because I read the article, of course, and I saw here Bloom's taxonomy, and you say that some levels of your system meets first, second, or third level of Bloom's taxonomy. Could you say more about this topic, about Bloom's taxonomy? Is it the taxonomy from 1956 or modified?
Дякуємо за запитання. Таксономія Блума використовується у нас для того, щоб за допомогою електронних курсів на платформі Moodle проводити, закривати першу сходинку, це знання, і за допомогою цього ми безліч разів перевіряємо знання, і далі за алгоритмом, якщо він не знає, то іде далі вчити. Якщо він виконує завдання, виконує ті поставлені цілі, він іде далі на навчання. Також за допомогою аудиторного навчання з викладачем, і також за допомогою вже електронного навчання ми формуємо другу сходину, це розуміння, і вже з викладачем в лабораторії VR-технології ми вже формуємо третю складову використання. Тобто ми вже формуємо алгоритм виконання дій. І він виконує ці дії до тих пір, поки кожна програма має можливість, кожний VR-курс має декілька курсів внутрі себе, Є такі курси, які проводять навчання, вони навчальні, там є підказки, там є правила дій і таке інше. І є асесмент, оцінювання. Там вже є виписані компетентності, і за допомогою VR-технології курсанти виконують ці завдання, і комп'ютер сам оцінює, виконав він цю компетентність чи не виконав. І потім вже викладач, маючи чек-ліст, знову ж таки формує за допомогою електронного курсу на Moodle або за допомогою вже конкретно роботи з цим студентом в аудиторії, формує нову освітню траєкторію з тим матеріалом, який він не продемонстрував, а потім знову йдемо на VR-курс, проходимо, і якщо ми набираємо 60 і більше балів, то курсант має можливість продовжувати навчання або має можливість знову підвищити свою оцінку. Дякую.
Okay, I understand, and I want to ask one more question about learning curves. If you incorporate your system learning course and repetitions, this is the main goal in didactics, so incorporating of neurobiology and the way that our brain, our memory works, how we learn. Do you have incorporated such or plan you incorporate such ideas in your system? Learning course, repetition, retention. You said that if the student does not meet the requirements, he has to repeat the part of the course or part of material and so on, but it can be also guaranteed, but using learning course and optimize the learning process, the didactical process at all. I don't know if you understand me. Try to ask.
Дякую за запитання. Наша відповідь така. На даний момент наші курсанти не мають можливості оцінювати за допомогою нейротехнологічних яких-небудь технологій, оцінювати їх стан. Але ж це планується у майбутньому. Ось, наприклад, у нашій статті було надано доповідь щодо використання білоруських вчених, їх досліджень стосовно нейробіологічних костюмів, які дозволяють оцінювати стан курсанта, наприклад, при проходженні деяких небезпечних моментів.
Стрес.
Так, стрес або їх емоційний стан, для того, щоб визначити найбільш небезпечні ділянки маршруту при проходженні яких-небудь плечей маршруту.
Okay, thank you for an answer. Do you have any answers? Any more answers, please? I have questions, please. So thank you very much. I think that no more questions. Thank you very much for very interesting presentations, and we have technical problems, but I think that we go to the end of our session, and all of us are happy that the presentation was impressive and very interesting for the audience. So thank you very much, and I invite you to the next session. I'm glad to see you, and I'm very proud that I'm with you, and I can be a part of your conference. So thank you very much. See you next time. So I'm closing the session. See you next time.
Dear Pavel,
Yes.
we are very thankful for you, for your help in leading this workshop, and the second year you are with us. Thank you very much. We appreciate your help a lot. And we appreciate very much your professionalism and your patience. Thank you very much. It is very helpful and very important for us. And your position and your comments and your participation, this is very valuable. Thank you very much for in this situation of quarantine and so on. Our workshop exists. We meet here, we meet you, and we will be very glad to cooperate with you in future in any mode, in distant mode, in hybrid, in person.
Thank you very much for a lot of warm words in my direction. I'm very glad I'm a part of your conference. I'm a part, if I can say, of your society of professionals in any aspects. I like to work with you and like the way you work and the level of scientific works, researchers you provide to the conference. I'm very proud that I can meet you. You, Maria, and Hennady Kravtsov, we met during the conference, and others I can see, of course. I'm also very proud that I can cooperate with Vladimir Molayev, who is professional, and Professor Spivakowski, of course. I think that we will meet in the future in Poland. Maybe we can organize the conference together with my university. But in my university, as whole Poland, we changes our education, changes our universities, which are transformed in the form of corporations. Yeah, it is a big problem for all of us because we are treated as ordinary workers, and not scientists, and it's a big problem for us at the moment. Everything, I think, will be changed because there is a problem with people in the universities. They don't want to work in the universities because of low wages, salaries, and so on. Yeah. And it's a big problem in Poland. You can earn more money on the market. Yeah. So I think that the same problem is with your universities, and I was very interested in some presentations where a situation of your educational system was presented, and the modifications the system you are doing now. Yeah, you are prepared for the future, and be a part of the system which still changes at the moment. Yeah. And challenges which take a part at the moment. So thank you very much for collaboration that I've met a few years ago. I think that we'll meet in Poland. We will cooperate in the future, and we will organize the next conferences together with my university or other universities in Poland.
Thank you very much. We are looking forward to meet you face to face. Yes.
Me too. Sorry for my language, because I occasionally speak English in the era of pandemic, and my English is not fluent as it should be. Yeah, it's a problem.
I think your English is excellent.
Okay, so thank you very much. See you next time, and I invite you to the next session of our conference. Be a part of the next session. So good luck, and see you again.